solving the WASSCE 2022 Physics Theory Past Questions, Part 1. This session covers key topics such as scientific units and measurements, concepts and properties of matter, kinematics, magnetism, fiber optics, electronics. These are important areas frequently tested in exams, so follow along as we break down each question step by step. Let's get started. So in this session, we are focusing on part 1, which carries 15 marks. And you have to answer any 5 questions from this part. And all questions carry equal marks, meaning each question carry 3 marks. In the next video, we will concentrate on part 2. Question 1. The period T of revolution of a satellite orbiting a planet of mass m is related to the radius r of the orbit by the equation T square is equal to 4 pi square r cubed divided by Gm. Using dimensional analysis, deduce the base units of G. So we have T square is equal to 4 pi square r cubed divided by Gm. And we know that T is the period, R is radius, M is mass, and we want the base unit of G. So first of all, let's make G the subject. Let's cross multiply. So T square will multiply Gm. So T square Gm will be equal to 4 pi square r cubed. And since we are making G the subject, we divide both sides with T square m. So we have G to be equal to 4 pi square r cubed divided by T squared m. And since we are using dimensional analysis, we have to know the dimensions of G. So the dimensions of G will be the dimension of R cubed. Since 4 pi are constants, so we are not going to concentrate on that, divided by the dimensions of T squared and the dimensions of M. To find the dimensions of G, we have to know the dimensions of mass, length, and time. The dimension of mass is m, and the unit is kilogram. The dimension of length is L, the unit is meters. And the dimension of time is t, and the unit is second. So the dimensions of G is equal to, now the dimensions of R, we know that R is radius, and radius is the same as length or distance. The radius is the length or distance between the center of a circle and the circumference. So radius is the same as length. So the dimensions of R is L, and we have Q here, divided by T is period, and period is the time taken to complete one oscillation. So period is time, and the dimension of time is t. So the dimension of period is t. we have square here. And m is mass. The dimension of mass is m. So we have m here. So the dimension of J will be L cubed, and the reciprocal of t squared will be t exponent -2, and m is at the denominator, so we have m exponent -1. But we want the base unit, not the dimension. So the base unit of J, base unit of J will be, now what is the unit of length? Length is in meters. So we have meter cube. And what will be the unit of time? Time is in seconds. So we have seconds exponent -2. And what is the unit of mass? That will be kilogram. We have exponent -1 here. So this is the base unit of J, and that answers question 1. Question 2. A wire of cross-sectional area A and length L is clamped at one end. A force F is applied to the other end of the wire to stretch it. The force produces an extension E in the wire. Write an expression for the A, strain in the wire. Now the strain in any wire is the extension divided by the original length of the wire. We also have to find the stress on the wire, and the stress on any wire is the force per unit area of the wire. And C, we are finding the modulus of elasticity of the wire. Now the modulus of elasticity is the stress divided by the strain. And we know the stress is force over area, and we are dividing by the strain, which is extension divided by the original length. So we have force over area times, then we find the reciprocal of E over L, which is L over E. So the modulus of elasticity is going to be FL divided by AE. A body is thrown vertically upwards. The height h attained in time t is given by h is equal to 20t minus 49 over 10t squared. Determine the maximum height reached by the body. We have h is equal to 20t minus 49 over 10 t squared. Now when a body is thrown vertically upwards, it travels to the maximum height and stops before coming down. So at the maximum height, the final velocity v is equal to 0. So we need the formula for velocity before we can solve this question. Now, velocity, acceleration, and distance are all related through differentiation and integration in calculus. So looking at this diagram, if you have distance and you want velocity, you differentiate distance, you get velocity. And if you differentiate velocity, you get acceleration. So moving up, you differentiate. And if you have acceleration and you integrate acceleration, you get velocity. And if you integrate velocity, you get distance. So coming down, you integrate. So now height is the same as distance. And we want velocity to be able to solve this question. So we are going to differentiate distance to get velocity. So now velocity is given by the differential of the height. Remember, the height is the same as the distance with time. So now velocity will therefore be, when you differentiate 20t, you get 20 minus the differential of 49 over 10t squared. It means that 2 will multiply 49 over 10, where we will have 49 over 5, and the exponent will decrease by 1. That's the laws of differentiation. And remember, at the maximum height, the final velocity v is equal to 0. So we are going to replace v with 0 and find the time taken to reach the maximum height. So we have v is equal to 20 minus 49 over 5t. And at the maximum height, final velocity v is equal to 0. When a body is thrown vertically upwards and it travels to the maximum height, the final velocity is 0. So we are going to replace v with 0 and solve for the time taken to reach the maximum height. So we have 0 is equal to 20 minus 49 over 5t. And we can multiply through by the LCM, which is 5. So 0 times 5 is 0. 20 times 5 will give us 100. And 5 times 49 over 5, the 5 will cancel out and we have 49t. And now let's take 49t to this side of the equation. We have positive 49t equals 100. And we divide both sides by 49, and t will be 100 divided by 49, which gives 2.04 seconds. And now we are going to substitute the time taken to reach the maximum height into the height formula to get the maximum height reached. So we have h equals 20t minus 49 over 10t squared. So the maximum height will be 20 times the time taken to reach the maximum height, 2.04 seconds, minus 49 over 10 times 2.04 seconds squared. And if you compute this, you get 20.4 meters. Question 4. A projectile fired from the ground level with a speed of 20 meters per second just missed the top of a pole 5.2 meters high. Calculate the angle of projection with respect to the ground. Acceleration due to gravity g is equal to 10 meters per second squared. Now the greatest height of a projectile is given by h is equal to u square sine square theta divided by 2g, where h is the height, which is 5.2 meters, u is the initial velocity, 20 meters per second, g is the acceleration due to gravity, and we are looking for the angle of projection, theta. So let's make sine theta the subject. We cross multiply. So u square sine square theta will multiply 1, and we have u square sine square theta. 2g will multiply h, and we have 2gh. We divide through by u square, and we have sine square theta is equal to 2gh over u square. We find square root of both sides. So square root of sine square theta is equal to square root of 2gh over u square. We cancel the square, and we have sine theta is equal to square root of 2gh over u square. So sine theta is equal to square root of 2 times acceleration due to gravity is 10, the height is 5.2 meters, and the initial velocity is 20, so 20 squared. So sine theta will be equal to, when we compute this, we have root 26 on 10. And we are looking for theta and not sine theta. So theta will be sine inverse of root 26 on 10, which gives 30.7 degrees. Question 5. State 3 industrial applications of magnets. Now there are a lot of applications of magnets, and we are to state 3 of them. This is a straightforward question. Now magnets are used to lift heavy magnetic materials in the industry. And also magnets are used in speakers to produce sound. Not only speakers, but DC motors and other a lot of devices. Magnets are used to separate ferromagnetic metals from non-magnetic material in recycling. Question 6. State 3 characteristics of lasers. Now the full meaning of laser is light amplification by stimulated emission of radiation. It describes how lasers work by amplifying light through a process called stimulated emission. Lasers are a form of light, but they are highly specialized, unlike ordinary light sources. And lasers have the following characteristics. 1. Lasers emit light of one color, that is, they are monochromatic. Lasers produce light waves that are coherent. That is, all points are in phase. Laser beams are collimated, that is, they have minimal divergence and remain nearly parallel over long distances. So these are three characteristics of lasers. Question 7. A. What is doping as used in semiconductors? Now, first of all, let's understand what a semiconductor is. A semiconductor is a material whose conductivity lies between a conductor and an insulator. And a semiconductor in its pure state, without any impurity added, is called an intrinsic semiconductor. Now, an impurity can be added to this intrinsic semiconductor to increase its conductivity, and the process is called doping, and that semiconductor becomes an extrinsic semiconductor. So the process of adding an impurity to a semiconductor to enhance its conductivity is what is called doping. All right. So doping in semiconductors is the process of adding small amounts of impurities to a pure semiconductor to increase its electrical conductivity. So the pure semiconductor is what we call the intrinsic semiconductor. And after the impurities have been added, we call it an extrinsic semiconductor. All right. So that is the A part. The B part, explain the effect of donor impurities on semiconductors. So what the donor impurity does is that it adds extra electrons to the semiconductor, increasing its conductivity and making it an N-type semiconductor. The charge carriers, that are the particles responsible for the conduction of electricity in semiconductors, are the electrons and holes. Now, the donor impurity rather add extra electrons to increase the conductivity. On the other hand, an acceptor impurity will rather add an extra hole to the semiconductor.
Yeah. Oh. Yo, yo, yo. Oh. Alpha, beta, here we go.